if we as a globe, as a world, can fund these really strong region-based agriculture research hubs. So like a subsistence farmer in Africa can go to a local extension agent that understands the community that this farmer is coming from, understands the environment that that farmer is growing food much better than I can understand it living in Virginia, and that is happening at a large scale across the world. We can have a really effective movement towards sustainability.
Today's guest stands at the intersection of ecology and agriculture, with a focus on how farms can stay productive and stable as climate pressures intensify. Uriel Menalled is interested in practical, real-world strategies that use biodiversity across crops, soils, and landscapes to build resilience rather than relying on single solution fixes. He's currently a postdoc in the Whitehead Lab at Virginia Tech, studying how the diversity of plants, soil microbes, and soil fungi can shape the chemical makeup of apples. And it's my honour to present him being interviewed by the brilliant Erin Hassett. I hope that in this interview you find something that deepens how you think about agriculture, ecology, and resilience in the face of a changing climate.
Hello. Thank you so much for joining me today, Dr. Uriel Menalled. It's a pleasure to have you on the show. For our listeners today, Dr. Menalled is an agroecologist by training and is a graduate with his PhD from Cornell and is currently at Virginia Tech, but we can get into the details about that a little bit later. And just as a little bit of background about you, which you will definitely elaborate on, you study agriculture systems, organic, no till, you look at weed ecology, weed suppression, and different farming techniques to research questions related around those topics. In a nutshell, you do a lot more, but just to get started, I'm hoping that you could give us a little bit of background about you and how you even got into this field. What was your inspiration and path?
Yeah, sure. Well, thank you so much for interviewing me, Aaron. It's great to, have some of your time to talk about sustainability and agriculture, and I'm really excited to participate in the magazine and this interview. So I got into studying agriculture kind of through a path where I went to a liberal arts school for 2 years when I started college, and I was doing some environmental humanities courses and getting into this idea of sustainability and land management and the interaction between humans, food, and the environment as kind of this nexus of human rights, environmental rights, and sustainability. And then I got the chance to do some research as an undergrad. In ecology and felt like my interest in becoming a scientist and working in agricultural systems was really worthwhile. And so that led me to transfer schools and go for a degree in agroecology. And so I finished my undergrad in agroecology, and then the next step was, I continued to like it. I went to grad school for agroecology, continued to like it, and now I'm kind of going for a career in agroecology based on these positive experiences.
So, agroecology for our listeners is literally the ecology of agriculture.
Yeah, that's correct. It's applying our understanding of ecological systems to agriculture, which, agriculture inherently is this interplay between nature and food production and I guess food and fuel and fiber actually. And so it's the application of ecology towards agricultural systems, hopefully to make them more sustainable, ethical, and equitable.
I can imagine how that is incredibly important globally, as food systems are what feed us all, and overpopulation could be contributing to maybe issues with our food system. But is there anything else about agriculture that you are interested in? Like, what specifically is threatening our agriculture systems that it makes it worthwhile to study?
Yeah, I mean, I think one of the biggest, personal ethical drivers of why I think investing my time doing agroecological research is important is because climate change is a huge threat to food security. And I'm really motivated to make sure that our future is one where everyone can be fed and, healthy food. And our future inherently involves climate change. And so trying to understand both how to design farm systems which have reduced greenhouse gas emissions, as food production accounts for roughly a quarter to a third of global greenhouse gas emissions. So, working in agroecology to reduce the greenhouse gas footprint of agriculture is really meaningful, but then also making sure that we're designing agricultural systems that are resilient to climate change is really impactful because we're getting these increased extreme climate events. And if we don't have resilient systems, just like that, you can lose a ton of calories. And that's happened numerous times in the world. Like, I think it was in 2020, China had these historic floods, and that affected about a quarter of all Chinese agricultural production. So, this is massive amounts of food. And so if we don't have these resilient systems, there's huge consequences that can, again, they can happen really quickly. Yeah.
And probably not just floods too, but I'm assuming droughts as well.
Oh,
And
absolutely.
I'm sure it's probably difficult for farmers to predict which one is going to happen every year and how to account for that farm management, as you said, like resiliency.
Totally. And not only is it difficult for farmers, it's going to continue to become more difficult for farmers, for scientists, forecasters, for all of us. I mean, that is the the challenge is greater extreme weather events that are unpredictable. Of course, we're living in this age of a lot of computational power and predictive tools, and that helps us predict climate change events, but we need to make sure that our farm systems are also, resilient for these unexpected events, which are becoming more and more common.
So, if you had to break down your research into different topics, how would you do that? What is it that your research physically looks into?
Yeah, so I think that there's two really big kind of streams of research that I'm interested in. The first one is really field heavy agroecological work, which is applying ecology towards the management of weeds and the management of crops. So I'm thinking about how to design really effective crop rotations based on the needs of crops and the ways in which weeds can compete most intensely with those crops. And being able to select crops in a rotation which can increase the success of crops and reduce the success of weeds without having to rely on things like herbicides or intensive tillage. That's a huge stream of my work. The second part of my work is more social, and this is stuff that I've gotten in lately, but it's asking what drives farmers' behaviors. For instance, me personally as a scientist, I just described that a lot of my moral interest in agroecology is driven by my perceptions of climate change and it becoming a greater reality. That's what motivates me to adopt or think about agroecology and farm system change. But that's not necessarily what may or may not impact farmers' behaviors. Perhaps they're more driven by bottom lines, like they need to make sure that what they're doing is economically feasible, or they're driven by their social perceptions, like what their neighbors will think if they, stop doing tillage and herbicides and have a lot more weeds on their farm and it looks messier. All of these things really matter. And so I'm interested in this social work in terms of understanding kind of socially what drives farmers' behaviors in terms of their adoption of farm practices. And I think that's both of those streams really play well with each other because if I can understand what affects a farmer's behavior, I can present and design field research which is more effective at actually reforming agriculture and meeting their needs, and not just being this self-perpetuating thing, which is purely my interest as an academic. So that's kind of my broad scale interests, and within that I can talk about kind of more specifics, but I'll keep it at that.
Yes. So, with that first topic, you're talking about like weed ecology and management. What does that look like for you when you're boots on the ground in the field? How exactly are you doing this work?
Yeah, so traditionally it's a lot of going to different research farms or in the current project I'm about to start real farms, not like university research farms, and then sampling weed communities. So using my botanical skills to identify species and then associate the species that are present or absent and their relative abundance in different management systems. So, for instance, next Monday, I'm going to spend the next month going around the state of Virginia to sample the weeds and the understories of 130 apple trees across the state. And each of these trees come from 5 or 6 farms. Each of these farms have different practices. And so my work as an agroecologist is saying, okay, statistically speaking, what are the management practices that farmers are using in these different farms, and how does that impact the weeds that are present or absent? And this is a really applied scenario because we're going to different research farms. More traditionally, a lot of my work is at a university research farm where I can control all the variables, and I'm really, really being specific about saying, like, how does tillage impact the weeds that are present or absent in soybeans or corn? Or how does the use of a cover crop impact those weeds? And so again, it's using botany in the field, and then the reality is a lot of statistics later on to be able to mathematically predict diversity.
What is the importance of understanding weed community? Because I can imagine or maybe guess that a farmer just wants to get rid of all weeds so that just the crop they're interested in is growing. So, what's the importance of understanding all the different species that are growing within the crop you're interested in?
Yeah, that's a great question. I think that weeds are fascinating because they simultaneously represent one of the biggest sources of yield loss globally. I can't tell you the percent right now, but there are scientific studies that look at a broad perspective what causes yield loss and find that pressure and competition from weeds is one of the biggest drivers of that yield loss. However, not all weeds are created equal in terms of their competitiveness to a crop, both in terms of some species being more problematic than other species, but also a weed that grows alongside a baby crop is much more problematic than a small weed establishing when you've got a huge crop plant. So, like, think of a baby corn plant, which is like a small kind of grass, compared to a mature corn plant, which can be, several feet high and have a really established root system. And so, understanding and predicting which weeds are problematic and when they're problematic lets us be much more selective in our energy in terms of, I say our, but farmers' energy in terms of weed management. And says, is this paradigm of saying, okay, you don't need to kill all of the weeds on your farm, both because that involves a lot of time, resources, which, by the way, these resources are oftentimes tillage, which uses a ton of fossil fuels, herbicides, which again is associated to fossil fuels, but also impacts the environment and human health, particularly applicator health. And also, you can conserve diversity. which adds resilience to this climate change. So weeds are fascinating, and thinking about the community of weeds, like not just every weed is created equal, but thinking of them in terms of like a function of all the weeds you see, and being able to understand which ones are problematic and not is a really great way, I think, to be at this interplay of promoting food access, because weeds are quite problematic, but also environmental health, because again, not all weeds are created equal, and the way they're managed conventionally is quite problematic.
Yeah, so how do you know when weeds are problematic and when to leave them alone and when to get rid of them?
That's a great question. That's now we're getting into science. I mean, that's the type of question that I ask myself on a daily basis. And the way we answer that question is through experiments that look at that might manipulate weed communities and see how crops respond to them, experiments that manipulate what's called the quote unquote critical period of weed management, which is basically the growth stage of the crop in which a weed species is problematic. Again, this idea that a baby crop plant might be much more susceptible than a mature crop plant. Um, you can have really specific greenhouse experiments where you like grow a crop plant with different densities of weeds, like all of these types of experiments, and then statistics after the fact help us answer that question. And that is a whole field of research and a really exciting one. And so yeah, that's um, the answer is there are many ways, but always through experimentation and then statistics, so that we can say, okay, with X number of certainty, we know that this is problematic under these conditions.
And you'd probably define a weed or weed community being problematic if you see, say, a decline in like the crop you're interested in. Say you're interested in corn, and if there's this type of weed community beneath that corn and you see a reduction in corn, then those weeds would be bad. But if you see this other weed community that's not impacting the corn as much, then you'd say that wouldn't be a problem as much.
Absolutely. Yeah. Of course, we're trying to like mathematically say, okay, we are certain that under these conditions, this community is not a problem because it has X number of traits. And there's a ton of interactions between like a weed community that's problematic for a corn plant might not be problematic for an apple tree, which has been established for many years. Um, And so that's a huge source of research. I'm actually part of an international collaboration on a project that's focused on understanding and defining basically something called neutral weed communities. So exactly what you determined. Like what are the traits in a weed community that makes it neutral or not problematic in terms of reducing crop yield? And so that's an active area of research for me right now.
Is there a way to select for the weeds that you actually want or don't want? Because biodiversity is good, as you mentioned, but maybe you don't want certain types of weeds that would impact, overall yield, but you don't want to use a lot of herbicide chemicals to reduce that. Are there ways to, in a more healthy environmental manner, have weeds that aren't causing problems?
Yeah, absolutely. I mean, weeds are highly responsive to farm management at every level. So you brought up herbicides. Herbicides filter weed communities. They're herbicides that only kill certain weed species and keep other ones alive. There are herbicides that kill all weeds or all plants that don't have resistance to the herbicide. But then there's a ton of other practices, right? Like things like tillage will tend to kill or uproot established weeds and promote a weed community that's more of like a annual plant that grows really quickly between tillage events. Mowing will kill a lot of weeds that have their growth points above ground. So for instance, you can mow your grass lawn because grass or a lot of grasses has growth points below ground, so it's not impacted by mowing in the same way that like some other broadleaf species are. So mowing, again, it's this targeted management tool according to growth points of plants. And then there's a lot more nuanced forms of weed management. For instance, a really active area of research of mine is how do cover crops compete with weeds? So cover crops are plants that are intentionally seeded by farmers, and they're seeded primarily not for their benefits in regards to grain crop yield, rather just to like keep soil in place and build soil health between periods of primary cash crop growth. And what I was finding is that cover crops not only suppress weeds, but they're most effective at suppressing phylogenetically related species. So it's this idea that if you're growing a grass cover crop, so like cereal rye is the most common cover crop in the northeastern United States, that cereal rye is going to be more competitive to phylogenetically related weed species, so grassy weeds. And so this is a great way to be able to select cover crops and have targeted weed management. Okay, so like if you're a farmer and you've got like a lot of wild rye weeds, we know that planting a cereal rye cover crop will occupy more of its environmental niche. It'll use more of the resources that that problematic grassy weed uses, and it'll be more effective at this targeted weed suppression. So we have this way of shaping the weed community without any herbicides or tillage or even mowing in this case. And so, yeah, again, you ask if we can have shape our weed communities, absolutely, at almost every level of farm management. Whether it's these like really powerful technologies like herbicides, or whether it's things like selecting the right crop or cover crop.
Do you think that cover crops are worth the time and energy investment to plant something that isn't necessarily what a farmer is going to make their money off of, to grow a crop or grow a plant that's just for the purpose of covering the ground? Is it actually beneficial to do that financially?
Yeah, so the answer really depends on where you are. So if you are in a environment that gets quite a bit of rain. And so by that, I mean like the northeastern, mid-Atlantic, southeastern United States, even some of like the eastern side of the Midwest, then you have enough water in your soil to really grow cover crops. If you're in a super arid environment, then that cover crop could be damaging your future cash crop growth because it's sucking up water. And that can be really problematic in super arid systems. Although there's some research on cover cropping in really arid systems. So think like the Dakotas, Montana. That's still an area of research, and it's not ruled out. It's just not as easy as somewhere like the Northeast.
So, do you then, in your research, consider different types of cover crops and how effective each type could be at?
Totally. Yeah. I mean, there's multi-site science that's looking at how the performance of a cover crop, say cereal rye, differs in New York State versus Virginia versus Wisconsin versus Washington, and trying to define those environmental gradients. But to answer your first question, are cover crops worth it? If you're in the right environment where like it makes sense to even start really thinking about cover crops, then yeah, it does. Cover crops themselves aren't incredibly expensive in terms of, I guess it really depends on the species of cover crop you want to grow, but like they're not necessarily tremendously expensive to buy seed or plant. It mainly just takes time to plant the seed, but it would also take time to till and time and money to till and buy herbicide. So so within the like spectrum of thinking that almost all weed management will cost some level of money and time, cover crops aren't that shockingly expensive. Also, we know that if you are in an environment that gets something like a lot of rain, like too much rain. So again, think like the northeastern United States. Extreme rainfall is becoming really problematic there. Cover crops can actually be really good, and in really rainy years can increase yields relative to a tillage-based system because farmers can get in earlier in the season as their ground is just dried up. It's not just this mud pit, and that can be really important for cash crop yield. So I would say if you're in the right environment to start thinking about a cover crop, then yeah, you should think about it. We've done a lot of, research which shows that objectively, if you make the right choice, you can do pretty good.
And so cover crops can not only be the solution to suppressing weeds and reducing your herbicide usage, but it could also positively impact your crop yield.
I think I would be careful with that wording. I wouldn't call cover crops a complete solution. They're part of the solution. So when you think about a system that is reducing reliance on these really, really powerful technologies like intensive herbicides or intensive tillage, you're going to need to combine many of these practices. And an example of the practice that I'm talking about is like cover crops. Like alone cover crops aren't going to be the silver bullet that's going to manage all your weeds and is going to give you the best yield possible. But if you combine cover cropping with selecting the right crop rotation and really using the proper varieties that grow really well for your specific environment, and you're really thinking about maybe doing some mowing or weed zapping or flaming of your weeds, this combination of practices can be the solution. Anyone on its own, not necessarily. But yes, cover crops, when used correctly, are unquestionably a powerful tool of weed suppression and can significantly increase yields. But again, it has to be in the right environment. And that's oftentimes one with precipitation and a growing season, which allows for, more than just one crop because you're in like really northeastern Canada where growing seasons can be really short.
And are these methods typically more common in organic systems as opposed to conventional? Or do you see conventional users also trying out these different methods as well?
You know, we're at an interesting spot where it really depends on the method. So cover crops, I I I I don't have any percents, so someone might be able to call me out on this. I think that cover crop adoption is higher amongst organic farmers and conventional farmers, but for instance, no-till farming is higher amongst conventional farmers than organic farmers because they're able to reduce tillage but then spray more herbicides to manage their weeds. So it's kind of like this maybe catch 22 a little bit, but still, good to reduce tillage. So it really depends on the practice, but cover crops in particular, yeah, I think they're probably adopted a bit more by organic farmers and conventional farmers. However, that does not mean they don't have a place in conventional farm systems. In fact, it can be arguably a bit easier to manage cover crops if you are willing to use some herbicides because you can terminate them quicker and more effectively. It costs a bit more money.
So the main differences between organic and conventional, I feel, might be a little blurry or a gray zone with the public. I think when people hear organic, they think no pesticides or herbicides at all, and that it's much healthier. Is that in general true, or are there differences beyond that?
Yeah, there's been interesting studies that have looked at nutrition of organic versus conventional at a really broad scale. It's hard to specifically say that organic is unquestionably healthier from a nutrition standpoint than conventional food. It's also, there's a lot of claims about conventional food having risk to human consumers. Um, and right now, it seems like for every study that shows there's correlations with different types of cancers, there'll be another study that shows that those correlations might not be statistically significant. But what there is that there is definitely unquestionable a lot like exposure to herbicides and chemicals through the consumption of conventionally farmed food. Like, it's unquestionable that traces of herbicides have been found in everything from urine to breast milk to neonatal fluids, dust in houses. So, like,
Well, organic farms can also use herbicides too, correct?
so by the definition of the USDA, organic farms are not allowed to use synthetically produced pesticides in general. So that includes everything from fungicides to herbicides to
But if
rodenticides.
it's but if it's natural, that's when you're able to use it.
Right. And so there are OMRI, which is the like governing body of the USDA organic system. There are OMRI approved herbicides or pesticides just in general. These are derived from natural products. So it could be like the concentrate of, some type of like citric concentrate, super high concentration of citric acid, something like that. That was just kind of an example out of the blue. But, you know, you, uh, right there is this ability to apply pesticides. They're not synthetically derived. I'll
Mhm.
leave it up to you to say whether or not that has
Yeah.
radical impacts on human health if you like concentrate something that's naturally produced to a high level and put that on your food, so yeah, there is this ability to apply. um Part of the organic standards are proof that you are building up soil health, but the reality is that a lot of organic farmers do a ton of tillage, and tillage is pretty problematic to soil health.
How so?
um Well, when you till soil, you're disrupting its particles. Like, literally, you're kind of breaking apart soil structure, and that makes soil much more vulnerable to erosion. And we're experiencing tremendous amounts of erosion. I, I think that I don't want to, yeah, I should double check this, but by some estimates, we've lost about a third of the world's topsoil due to erosion. And so that's tremendous. Of course, we've been around for a long time, but we know that there are landscapes that have been overgrazed or overfarmed, and they lose their viability in terms of producing food because of soil erosion. And so to say that there isn't a huge issue with soil erosion in organic farm systems would be to ignore a huge sustainability issue there. And
Mhm.
so I think your question was, is organic automatically better? Well, it's a nice step in the right direction, but not all organic farms are this like wonderful example of sustainable food production. However, I do think that like the public and government interest in having guidelines to improve soil health and reduce the use of synthetic pesticides, which, although there's a lot of scientific argument on their impact on consumers, there's definitely an impact on applicators, on the farmers who are applying these synthetic pesticides. Like, all of these attempts are very worthwhile. And so we should continue to really be thinking about organic food and sustainable food and how we can make it part of our political and economic discourse. So I don't want to
Yeah.
discredit organic food either.
So you're breaking your research into two different groups, and the second being farmer surveys and actually discussing your research and farming practices with the actual people doing the farming in the field. What are you seeing in their conceptions of these practices? Are they super interested in cover cropping, no till? Let's see, you also mentioned crop rotation. Are you asking them whether or not they do these practices and how
Yeah.
they're
Yeah. So my most recent experience with kind of the social element of sustainable agriculture was this analysis of a farmer survey that was sent out to over 1,000 organic soybean and corn farmers in the United States, of which we did our analysis on, depending on the question we were asking, based on just farmers completing the question and not leaving it blank. anywhere from like 420 to 120 respondents, roughly. And so with this national survey, we were asking farmers questions like, what are your interests in reducing tillage? Or what are your interests in adopting intercrops? So things like not just growing a monoculture of corn, but maybe growing that corn on other crops, say like a clover crop. So it's not just corn.
Would that be like to balance the nutrients so that your one crop isn't just extracting everything, or
Yeah, you can balance nutrients, promote biodiversity, keep more soil covered, and reduce erosion. These are all things that have been found to significantly be increased by intercropped systems. So various practices like that. And we found some really interesting results, which is one, these are organic farmers, so it's not like all corn and soybean farmers. They're specifically organic farmers, but they are interested in tillage reduction. They are interested in practices like intercropping. They're also interested in more technological research on things like really specific mowers or weed zappers that can help them manage weeds without using a tillage implement. They're interested in these more systemic level reforms like intercrops. Um, they prefer to learn through farmer to farmer communication. That was the most preferred form of acquiring new information for this pretty big survey of farmers. And that was significantly and statistically higher above any other form of information access that we talked to them about.
do you think that could be problematic for researchers to disseminate
No,
information if farmers would prefer to hear from other farmers?
not at all. I think it helps us as a research community reframe our outreach programs, and it does things like it shows us that doing on-farm research is really important. Like for instance, this research program that I'm doing across Virginia where I'm talking to farmers is a great way to share my work directly with farmers and involve them in the research practice as like there's an experiment happening on their farm. I think that when you do that, it has a bigger chance of entering their conversations with other farmers instead of just me doing an experiment on a research farm, publishing it in an academic journal, which sometimes can be behind a paywall and probably will not make it into farmer to farmer conversations relative to, me actually doing my science on a farm. Or for instance, as academics, it helps us realize that like for instance, extension services should do things like have farmer discussion panels, right? So they're facilitating this farmer to farmer communication instead of doing this top down approach where an extension agent goes to a community center in a rural farm county and just gives a talk and leaves. Okay, so that's really valuable information for the academic community. And it doesn't, I don't view it as like as something that intimidates me. It makes me excited. It helps me rethink about how to do impactful research. And then the other finding that I thought was really interesting is what motivates farmers to reduce tillage. Like I said, like the things that motivate me to study tillage reduction are climate change. And in as someone who has been living in the Northeast for a couple of years, it's particularly like extreme precipitation causing soil erosion and tillage being a really big contributor to soil erosion. But we know that a farmer's experience with extreme precipitation doesn't impact their odds of actually adopting no-till practices. Their perceptions of the costs of organic no-till or the availability of equipment to do this practice, that significantly impacts their odds of adopting this technique. And so what it means to me again is like when I reach out to farmers, I might be really interested in saying, "Hey, you live in the northeastern United States. That's the region of the United States that has seen the biggest percent increase in extreme rainfall in the last 50 years, and whether or not we have a moderate to high emissions future, it will continue to be the region of the United States that has seen this big percent increase in extreme rainfall. Therefore, you should reduce tillage." Like it drives me necessarily not like kind of away from that approach and more towards an approach of saying, okay, well, there's these experiments that show which that like under certain no-till practices you can save time and money because tillage is really really expensive, and this is the equipment that you need to do this, like replicate these studies in your farm system, right? It
So
shows me that like I can set up my research in a way that's more palatable and interesting in a farm. So, I'm bridging this gap between my interests and farmer interests.
So they're particularly interested in the economic benefit and translating your research into, well, if we were able to get these types of tractors, this type of equipment, then we would be able to do that.
Yeah, at least in the case of organic corn and soybean farmers, yes, their odds of adopting no-till or tillage reduction practices were driven by their understanding of the equipment that they needed to do these practices and their understanding and perception of the costs of these practices, not their experience with things like drought or extreme precipitation. So if I'm a farmer in Pennsylvania and I've experienced a huge rainfall event, at least what the survey shows is that that doesn't necessarily impact my odds of actually reducing tillage. But if I go to a farmer discussion panel that includes on-farm research where these farmers did research alongside a scientist and an economist, which showed that doing things like using a cover crop mulch to manage weeds instead of tillage made economic sense, then I might be more convinced. My odds of actually adopting this practice are changed. And so that's really valuable, right?
Mm,
That shows me how I can
that
have
is
a
really
meaningful career.
that is very interesting. Did you see any changes in perceptions across the United States? Like, were people in the Northeast more likely to do something compared to the West, where the agriculture is entirely different?
We did do the survey across the United States. What happens is that most corn and soybean in the United States is farmed in the Northeast, Midwest, and kind of like the Mid-Atlantic slash kind of Ohio Valley area. And so this region is where we got the majority of the responses because there is a climate that is most conducive to corn and soybean production. And there wasn't a tremendous amount of variability across these three massive climatic regions. There were a couple of corn and soybean farmers in the West, but like across, so this was a answer that had like 420 responses. I think there was like roughly five corn farmers in the southwest of the United States, which makes sense because that's a region that doesn't grow much corn. So, of course, these farmers have a completely different reality than a farmer in Wisconsin who grows corn and uses different practices, but they're a really minority in the survey. And so it makes them hard to study from a statistical perspective because there's like five versus, 120 responses. So it's tricky. But yes, location matters at a large scale. Just the majority of farmers, in this case, not so much.
Is there anything that you think is left unanswered in that research that you'd like to see moving forward? Any kind of gaps?
I like what I would love to do is do work that like simulates different types of climate change events on farms and understand whether that impacts a farmer's reaction. So like again, it seems like a farmer's experience with like an extreme rainfall event that happens across their entire farm doesn't change their behavior. But like if I go to a farm and am able to simulate an extreme rainfall event and a farmer can like see side by side their crop, which grew in one or two less extreme rainfall events, and same crop right next door, which grew in a couple of artificially simulated extreme rainfall or drought events, and have this physical comparison side by side, if that will change their behavior, right? Like, again, I'm really concerned and interested about climate change. And so I understand that farmers need to work in bottom lines and they're really motivated by things like profits and equipment availability, as well as other value systems that aren't strictly economical, but economics are a huge perspective. Um, the question that I would love to see is like, how can I effectively educate about climate change in a way that actually changes behavior and not just keep talking about bottom lines? Because frankly, like, not all sustainable farming practices meet the bottom line, and that's why they're not widely adopted, right? Like there are other values than just economics to sustainable farm practices, like increasing biodiversity or climate change resilience in and of itself is a benefit, even though it might cost more. And so, yeah, being able to understand how to communicate to farmers in a way that's not just about equipment access and the bottom line, I think is critical. So that's what I would like to think of.
In your pipe dream, and if we could take your research and what you've learned from your work and upscale it globally, what would you like to see? What's the global solution to our agriculture issues?
Oh, okay. That's a huge question. The answer is there's no silver bullets in agriculture. Okay? Like there's no like simple, easy, like I can't say everyone should adopt a cover crop because frankly, cover crops are not a good way to manage water or money in some environments and locations. It's hard for me to say that like we shouldn't use herbicides at all because we have billions of people to feed and not everyone is ready to get rid of this really effective tool. So like it's hard for me to say like there's one solution to food. But I will say this. I think because agriculture is extremely context dependent, like your environment matters, your socioeconomic status matters, the crops you grow affect everything. We need to invest in really strong agriculture research and extension networks across the world, right? Like, it doesn't make sense for me um, at Virginia Tech to do research which is like immediately applicable and make these sweeping conclusions that can help a small scale farmer in Africa, unless I am actually able to go there and research their system and understand their value networks. But instead of maybe me going there, I think if we as a globe, as a world, can fund these really strong region-based agriculture research hubs. So like a subsistence farmer in Africa can go to a local extension agent that understands the community that this farmer is coming from, understands the environment that that farmer is growing food much better than I can understand it living in Virginia, and that is happening at a large scale across the world. We can have a really effective movement towards sustainability. So it comes again at this idea of global investment in regional sustainable agriculture research
Definitely, yeah.
and teaching, research and teaching, right? Because like research on its own is cool, but it needs to be translated and bridged to farm communities. So
Definitely.
I think that's probably the most responsible answer rather than just saying like stop tillage or stop herbicides.
No,
So
for sure. And everyone's needs are different, and the landscape provides, different environmental factors that could be influencing crops in different ways. So, yeah, no, it makes sense that the silver bullet doesn't exist and one size does not fit all. I just know that our food system has is always being talked about, especially with climate change, and to just make sure that we're continually working towards healthier, resilient food systems is
yeah.
like incredibly important. And it's great that you're doing like involved in it in your part.
Yeah, thanks. And I will say, so like just to give a bit more specific as to what I mean, so I'm not maybe like giving this like broad, wishy-washy answer. I have a lot of respect for the American extension system. That does not exist everywhere in the world, right? This idea that we have or should have county level agents across all of the United States that are working for the public interest. Okay, like a lot of countries don't have that. And so you have crop consultants that can be representing their company's bottom line. Like, and these crop consultants can be really smart and they can be helping people. But this idea that, extension isn't perfect, American agriculture is certainly not perfect, but this investment a long time ago that exists today, like it's existed for over 100 years in regional based, publicly funded research at the county level is wonderful. So that is a great example of how we can have science and agricultural science and research for the public interest at a regional level. And hopefully, extension systems are supporting sustainable agriculture, which is not always the case. But like that is specifically what I would like to see across the globe, like public interest research.
Yeah, I think that's a great addition to
Yeah,
your previous. Yeah.
because there's a lot of money and resources and research from the private sector of agriculture, but that isn't necessarily, I think, the best way that we can have research for the public interest, frankly. So,
Yeah. And you've had a new position at Virginia Tech. So, just to transition into future work, future steps, you're going to, as you mentioned, going to be researching apple orchards and the wheat communities beneath those. Any anything else upcoming with that work that you'd be interested in sharing or that you hope to do in the future?
yeah, I mean, the project that I'll be working on at Virginia Tech is looking at how the diversity underneath apple trees, whether it's weed diversity or like planted row cover diversity, impacts the quality of apples. And so this is kind of a shift for me because in the past, a lot of my research has been strictly based on yield, like how do we produce more food? The question here is how do we produce healthier food? And so that'll involve a lot of like field sampling of diversity, but then this whole new set of skills that'll develop in the lab of testing food quality. And so I'm pretty excited about that and to think about food production not again just from strictly like how many calories are we producing, but also like what's the like nutritional value of those calories and can we produce the healthiest food possible and like how do farm practices influence the nutrients of food in
That
this
is really
particular case.
interesting.
Yeah, in this particular case it's apples,
So, how do you
but
take two apples and say this one is more nutritious than this one?
you do an experiment in a controlled scenario, and so theoretically, the main difference between those apples is just the farm practices, like the variety of apples, the rootstock of the apple tree, the age of that, all that is similar. You take those apples to the lab, and then you get profiles into their nutrient contents. You can see if farm practices impacted the nutrient profile of apple A versus B. And of course, you'd want to have more than one replicate of these apples so you could do statistics on them and then you could get into some fun in terms of saying, okay, fertilizing with compost versus synthetic fertilizer has this impact, or it doesn't have this impact. And so that's kind of the direction I'm moving in with these projects at Virginia Tech. And they'll be in Susan Whitehead's lab. So I'm currently a postdoc. So, yeah.
That's really great. I'm glad you brought that up because more food doesn't always mean better or good food. So, yeah, nutrients make sense. That's cool that your work is kind of morphing along those lines.
Yeah. I mean, we need to feed everyone, but with healthy food. Right. And so, like, yeah, just healthy food is a important part of sustainability. So I'm excited.
Yeah, congratulations. And, well, I don't want to take up much more of your time. Thank you so much for joining me today. It's been a pleasure talking to you and learning more about your work and clarifying some questions I've had about agriculture research. And yeah,
Yeah, likewise. It's been a pleasure to be interviewed by you, and yeah, thank you so much for this opportunity, and Yeah. Thanks.
Bye. Thank you.
Bye.